I'm on a bit of an AI kick today, so I want to tell you a little bit about some intuitions I have when it comes to building AI for yourself and building your own models, specifically working with data that might be, kind of new to you, that you haven't processed, you haven't worked with yet, right? So I have this intuition when I was a beginner, like my first stages trying to build these things. The idea for me was, build a network that can do something with this data. And that idea was what stuck in my head, is my attention was on the model that I was using, the structure of the network that I was building. So I had questions like, how do I have, what is the right number of, nodes I should use for this network? What's the right number of layers? What's how many nodes per layer? What activation functions? What this? What that? The whole rigmarole. But often enough, and I love this insight. I think I had this myself, but I also saw it articulated on Twitter. But the idea is that, you're trying to, the most important part of building networks that can glean information from your data is to make your data such that networks can learn from it, right? The information is as important as the network itself. Honestly, likely far more important. So, for example, I'll give you some weak examples, right? So if you just have a set of random noise, right, you can load up in some Python script, with a line or two, just a whole collection of randomness, right? You give it to a neural network, and no matter how well you structure, it's not going to learn anything because there's nothing to learn there. It's strictly random, right? But if you structure the random noise, it's that, you make it random, but then you sort it out. Maybe you put all the high numbers up at the first part, in the first section of your inputs. You put all the low numbers in the last section, and you start asking it fake, arbitrary questions like, is this data set summed to a positive number, right? This is a weak, mathematical example. I can't come up with a better one for the time being, but you can take your random data and you can fake it into actual data, and your network will start to learn structures that really weren't even there in the first place, structures that you engineered. So in a sense, the network is kind of learning about you and how you structure your information. So just like that, you have a network that can just like that, by changing your data, a network that first of all would have learned nothing can now learn something, even if it's fake. But the same thing applies to data that is, legitimate, right? So for example, I'm working with patient data at the moment. I've been trying to predict recently COVID ICU admission. So if somebody is infected with COVID, they go to the hospital, they get administered. The idea is, can you predict whether or not they're going to need to go to the ICU or not? So the first part of that is the processing. So I'm using notes. I'm using free text clinical notes. I'm all about natural language processing. That's my game. So I'm taking data from in word form, and I'm trying to use that to predict everything else that I want to, specifically like ICU. So how does a neural network process words? Well, by default, it doesn't, right? Like by in its natural state. Oh, that's an airplane. Oh, that's a big airplane. No, get the airplane. I'm sorry, I missed the airplane. It was huge. I like an airplane. I'm sorry. I'm easily distracted by things that wonder me. By default, a word has no available input into a neural network. It's just kind of unprocessable until some brilliant people came up with some brilliant ways to translate words into something that a neural network can work with, articulate. That's not the word. And if you're interested in that, they're called word vector embeddings, right? There's a couple. The big one, the first one was like word to vec. It's just an algorithm that can take a sequence of words. Imagine you've got a Wikipedia page, right? Imagine that's your entire training set, right? It can take a sequence of words and it translates them immediately into some set of numbers, some random set of numbers at first, okay? And then it iterates one word at a time, one of these sequences of numbers. They're called vectors, these lists of numbers. One of these vectors at a time, and it tries to predict, based on the vectors surrounding it, what might this vector actually be, all right? And then it updates that, and then it does it for the next one, and then the next one, and then the next one. You see the standing line? Bam. Beautiful. and it updates that for the next one, the next one, the next one, all the way through the corpus. It does this, a couple thousand times, and not just a single Wikipedia page. There are these Word-to-Vec representations that use all of Wikipedia's like 6 million, 30 million some odd articles, right? And there's more recent versions. I used Glove for my research, and it worked out well, but there's cutting-edge stuff, uses what are called transformers, which do this in a really, like, just in a wise way. All right, it's quite something. So the idea, though, is that you have your input data that from originally a network could learn nothing from, and with some thought, some real like time and energy put into how you want to structure that data, you can come up with something brilliant. All right, you can come up, the idea, you can translate it into something useful for your neural network, and the rest is kind of history. Plenty of different configurations and architectures and this and that of a neural network can learn the same thing from the same data that you give it, right? And the reason why is because neural networks are very vast isn't the word. What word am I looking for? Neural networks are very variable. Damn. Sometimes the word just doesn't work. I'm sorry, and it's gone. All right. Neural networks, they learn different things. I'm going to hunt for this word. They learn different things. They versatile. That's the word. Yeah, neural networks are very versatile. They can pick up any configuration, can pick up a whole sequence of different kinds of patterns depending on the data that you give it. So that tells me that the common denominator isn't, well, truthfully, the common denominator isn't always the data. It's not always a network, but pay attention to your data and how you represent it to the network, because often enough, that's going to be the make or break point for how well the network can learn. You can think of it like this. If plenty of networks can learn from your data, right, but no network can learn from bad data. So first, pay attention to how you fix your data. That's it for this one. Have a good one. Peace.